Hey, welcome aboard, folks. Welcome aboard. Let's do some experiments today, shall we? We've got some flasks up here. We've been starting to test different brands of water to see their pH. You'll see this one here. It says pH 8.4. Let's give it a shot here. How you doing there, Master? Let's pour a little in here. Hello there, Gigabean. Welcome aboard. So this is what is this? The Icelandic glacial water. They say it's pH 8.4. I don't know what it is. I mean, I've got no reason not to believe them. There it is. That's what we're testing. There's the flask of water. All right, here's our pH gradient. All right, that will the color gradient that we may see. I'm going to go ahead and add the universal indicator here. Universal indicator is also known as rainbow indicator. You're going to see me pull it up here in this syringe. Well, pipette, I should say. Yeah, it's got a green color. And let's see what happens when I add it to the Icelandic glacial water. It looks like it's staying around a red color. Excuse me, a red color. Like a bluish green. Yeah, just slightly blue-green. That's going to indicate just a little bit greater than a pH of 7. We're looking at, I'm guessing that's around pH 8. Hello there, Gigabean. Yeah, so that's looking kind of interesting. I think we can maybe do the same thing here with, I don't know, let's try some Aquafina. I'm going to try some Aquafina water. Actually, I don't have a bunch of this, so I'm just going to add this straight to the bottle. So let's just go ahead and add the universal indicator straight to this bottle of Aquafina, which I will then throw out. I will not be drinking this, of course. So, by the way, Aquafina, you'll notice they say, this says pure water. Yeah, pure water. So let's give it why do I do pH on my live streams? Well, it's just kind of easy to do, and I thought I'd mix it up a little bit. With doing some water testing. Here we go. I'm going to go ahead and add a little bit of our green universal indicator here. And notice when I add it to the Aquafina water, well, we get a shift to a yellow color. Yeah, and that tells us that it is purified water, by the way. Aquafina is purified. A lot of people don't like the taste of it. And that's because most people don't like the taste of purified water. But anyways, if we check out that color, we'll see the pH is like 6, which is acidic. So why would purified water be slightly acidic rather than closer to neutral or slightly basic like this? I mean, it should be, it should be green. It should be neutral if it's pure water. Well, why is that? Well, that's because in any sample of water, like all of these that are exposed to the atmosphere, some carbon dioxide gets dissolved into the water. And when carbon dioxide gets dissolved into water, it lowers the pH. Probably not, Isaiah. Probably not. So let me just show you this here. I'm going to go ahead and I'm going to exhale into this through this straw, which of course will be blowing carbon dioxide into the fluid, correct? And if that happens, the mixture should get a little more acidic. I don't know how to do that, Adolf. Have no idea. Indeed, Master, CO2 is indeed acidic. So let's see if we can show this. I'm going to go ahead and exhale through this. Here we go. Give it a shot. There you go. Lowers the pH. The carbon dioxide from my exhaled breath lowered the pH because carbon dioxide in water is indeed acidic. And that's why we got a yellow color when I exhaled through that. Isn't that interesting? And so that's, that any water that's going to be exposed to, any water that's been exposed to the atmosphere is going to show that particular shift. Let me show you this again with, let's see if I have some, yes, I've got some Essentia water. It's fun to do with Essentia. It's like #1 ionized alkaline water. It's just a bunch of, BS. It looks like sorcery, but it's not. It's science. I'm going to go ahead and add some of this Essentia water, which they say is pH 9, 9.5. So when I add universal indicator to this, you know, we should see according to the pH scale there on the back left, we should see like a blue or a violet color. Let's see what we get. Let's see what we get. So there's my alkaline water. Alkaline just means high pH. So here we go. We're going to add in. You can see the green universal indicator. In it goes. And sure enough, that changes to a violet color from the, you know, the bases that are added to the Essentia alkaline water. But check this out. Watch how much carbon dioxide from my exhaled breath it takes to neutralize this. Are you ready? Now remember, carbon dioxide is acidic, so it should not only neutralize this, but if it neutralizes all of it, it should, as I continue to bubble it in there, it should tend to go acidic. So we should see a color shift, right? If carbon dioxide is indeed an acid, we should see a drop. Do I have stronger acid than hydrochloric acid? Not with me. No Breaking Bad here. I'm not a synthetic chemist, and I'm not Breaking Bad anyway. Anyway, let's exhale into this and see what happens. Remember, when carbon dioxide gets into water, it is indeed acidic. So let's see if this is the case. Here we go. Into our pH 9 or 10 essential water. You can already see it shift to blue. And as I continue to swirl the carbon dioxide that's already gotten in there, it slowly reacts with water. And that's why you're continuing to see a slow color change. I wonder if I already put enough in there to neutralize. I sure did. And maybe even acidify the alkaline water. So, you know, people sell alkaline water to alkalize your body. But did you see how long it took me to exhale into this to acidify the alkaline water? Not a whole lot. And so, you know, if you're trying to alkalize your body by drinking alkaline water, you know, you might save your money. It's a little bit green, so I'm going to continue to blow here. And there we go. That should pull the pH to pH 6, and it's going to look much, much more yellow. Kind of interesting, huh? Kind of interesting. I'm going to go ahead and just top this off with a bit more water, and then we'll start doing another experiment. That's kind of fun. Just so we can see it a little bit better. You can see the water that I'm adding from my tap is causing a shift to a slightly more green color. That's because the water from my tap is indeed a little bit basic, and that's why we're seeing it turn to a little bit more green. Lord, I cannot get the water to be that acidic through my exhaled breath alone. Thank you there, Stellarino. Appreciate that. Appreciate the vote of confidence. Okay, so let's try this here. We're going to do, here's what I'm going to do. I'm going to add some milk of magnesia. I don't have any copper ions on hand. Sorry about that. We're going to add some milk of magnesia, which is not too strong indeed. I'm going to add milk of magnesia. Yeah, that won't be happening on my channel, Pirate King, but thanks for the suggestion. I'm not a synthetic chemist, Andrew. So here we go. We're going to... No, I'm not a wizard. I'm just a chemist. We're going to put some milk of magnesia, which is magnesium hydroxide. You can see it's got like a milky color. That's because there's a lot of solid in here, solid magnesium hydroxide, and a little bit of it dissolves, but most of it stays undissolved. So that looks kind of cool dripping in there. Look at all those little drips, and in each drip, there is a bunch of solid that's there, okay? There's a lot of undissolved magnesium hydroxide. Now, when I swirl it, a little bit of it, thanks there, Andrew, a little bit of the magnesium hydroxide will dissolve. So here we go. Let's start swirling and see if we can't get some of the magnesium hydroxide to dissolve. It might take a little bit. You might notice that color is getting a bit more vibrant green, and that's because the magnesium hydroxide is a base. It's alkaline, and so as it dissolves, it's going to raise the pH. And you can see that's a much more vibrant green than it used to be. And if we continue to swirl here, what is this solution? Well, technically, it's not a solution because there's some undissolved solid particles that are in there. That's why this has kind of a cloudy look. But some of the solid does dissolve, and the solid that dissolves makes the pH go up. That's got a little blue tint to it now, doesn't it? I'm going to swirl a little bit more. How long have I been in the field of science? It depends on how you define that. I started studying to be a chemist back in the 1980s. Hello there, Vessi. Welcome aboard. Welcome aboard. That might be as much as we're going to get dissolved. That might be. So what is it? It is magnesium hydroxide from milk of magnesia that's been dissolved in some water. That also contains universal indicator. Universal indicator displays, hello there, Sarah. Universal indicator displays these colors at different pH values. So you can see we kind of like got a pH of 8 right now. Okay? Now, here's what I'm going to do. I'm going to add some acid. I'm going to add stomach acid. It's just not technically stomach acid, but this is hydrochloric acid. It's the same acid that's found in your stomach. It's just this stuff is a lot more concentrated. I'm going to add 2 drops, okay? So let's add 2 drops, and that should neutralize any of the magnesium hydroxide that has dissolved. And it also makes it go to red, but then the color shifts, okay? So there's a lot going on here. Let me go ahead and give this, let's see if we can't get it to go red just for a bit. So I add an excess of acid, so the pH goes to red. But the solid that's left continues to react with the hydrochloric acid that I've added, and it neutralizes it. And you can see the color shift. You know, the pH starts to get higher again. So we started at red, and now it's shifting through orange, yellow. See if we can get it back to green. It takes a little bit. Hello there, Dual. Hello there, Rajveer. It does look a little bit like alchemy, but it's science. It is definitely science. And it's taken a little bit long. It's a little bit longer than I'd like because of the slow dissolving of the magnesium hydroxide. I think this will work better if instead of using my tap water, I go ahead and use deionized water. So let's try that. Let me just, I'm going to empty this out. Give me a second here, and we'll try it with some deionized water. So I'm going to get this flask emptied. Okay, let's try this. Thanks there, Gunnar. Hello there, Vicky. Okay, let's go ahead and add some, you can see it here, distilled water. That's what I'll be adding to this flask. I want distilled water because I don't want a whole bunch of other ions messing with everything. All right. Hello there, Salacia Hot Dog. Here we go. Let's pour some in. Okay. All right, we got some water in there. Oh, all right, now I'm going to add the universal indicator. What am I making? I'm just making a bunch of fun. We're just doing some science experiments is all. I'm going to add universal indicator. Here we go. Remember, it's green at neutral. In it goes. And we see it's got a yellow color. We already know why that has a yellow color from the carbon dioxide that's dissolved into the water, making it slightly acidic. Hello there, Jason. Okay. Now, I'm going to add the very basic milk of magnesia, which should introduce a lot of base into the solution. So here we go. Here's the milk of magnesia. Hello, Comedy. Hello, Pink. Gold nanoparticles. I'm not going to be making any of those in my basement anytime soon. All right. So in goes the milk of magnesia. Notice it's a cloudy white. That's because there's a lot of undissolved solid in here. That's the magnesium hydroxide. And when I give this a swirl, some of the magnesium hydroxide should dissolve. Just falling in a bunch of solid particles that are suspended in a little bit of water. Let's give this a swirl and see what happens. Here we go. Look at that switch to a green color immediately. That makes a lot of sense. That makes a lot of sense. Right now we're at blue. We're like pH 8. So we start at pH 6, and as the magnesium hydroxide dissolves, we're seeing a shift to a higher pH. It takes a while for the magnesium hydroxide to dissolve, but if we let that go long enough, that may end up at like a blue or even a violet color. So here's our pH scale here in the back left. Look at that. gorgeous blue. It's almost like a violet now. It's a really pretty color. If you drink it, do you become the Hulk? I think, there we go. We got all the way to pH 10. I think it's used as a laxative, so you can get an idea of what would happen. I don't think you'd turn into the Hulk, but, you know, I think it might ruin your afternoon. Anyway, now, let's try to remember what's in this flask. There is some salt that has dissolved, just a little bit. The little bit of salt that dissolved has introduced hydroxide ions, is what they're called, to the solution, which has caused the pH to rise, okay? There's also some undissolved solid there, which is why this solution is not transparent, but kind of cloudy. Can I get it more purple if I keep swirling it? Let's find out. I don't think so. And the reason why I pretty much know that it won't continue to get more purple is because this pH indicator stays purple at pH 10 and up. Okay? So that's just, you know, we get to a point where it's just as much as dissolved as can. Now what I'm going to do is I'm going to add 5 drops of hydrochloric acid, and that'll neutralize the dissolved hydroxide. And then there'll be some excess acid, which will make this acidic, and the pH is going to drop like a rock. But it won't react with the undissolved solid. The undissolved solid will slowly react with the remaining acid, and then the pH will come back up again. So there's like a rebound effect. When I first add the acid, the pH drops, and then as the solid that's in there continues to react, the pH will rise again. Here we go. Let's go 5 drops. 1, 2, 3, 4, 5. I'm going to give this a nice swirl, and let's watch the magic. Here we go. There's your red. There's your orange. Oh, I added quite a bit, so this may take a while. Oh, I shouldn't have added 5 drops. This is going to take a bit. If I didn't add the indicator, it would look like a slight white color. Boy, it's taking, oh, there we go. I see it going to orange. There's your yellow. There's your green, baby. Come on now. That's just cool. Love it. And the magnesium hydroxide should continue to react, but slowly. Thank you there, X-ray. Can I mix potassium nitrate and sodium bicarb? I can. I just don't have any here, and I don't have any potassium nitrate with me. Thank you there, Atharva. Thank you there, Comedy. All right, hey, let's add another couple drops of hydrochloric acid. Here we go, because it's going to take a little while to get that to go all the way to violet. I don't want to wait that long, so here we go. Thank you there, Comedy. I appreciate the vote of confidence. I had like 2 drops of acid this time. There's your 2 drops. Let's give her a swirl. There's your red. And as the solid continues to react, that should switch back. There's your, is it orange yet? Not quite. Thank you there, Vessi. Appreciate that. Would sodium hydroxide do the same? Asked John Smith. The sodium hydroxide is going to shift this to your high pH. Thank you there, Ashley. I appreciate that. So, John, if I add sodium hydroxide, here, I'll add a couple drops. Let's see. Here's the sodium hydroxide solution for John. Let's go 2 drops. That may get us to violet if I do that. Sure enough, it does. Hey, there you go, John. What a great idea. Thank you there, EMH. What a great idea. I got a way to, speed it up. So here we go. Let's add the acid. I think I'm going to need like 5 drops. I might need more. John coming through with a great suggestion. Let's give that a swirl. There's your orange, your red. And then as the remaining undissolved magnesium hydroxide reacts, it shifts back to that green color. And then, of course, we're going to kick it with some sodium hydroxide to make it go a little more quickly to get us back to violet. Beautiful. Come on, John. Thanks for joining the chat. That's what a great idea. I love the colors too there, Lord Stormia. Hello there, Oleg. What's the other reactant? So, John, what we have in here is some solid magnesium hydroxide from Phillips Milk of Magnesia. We have water, and we also have universal indicator. That's pretty much it. And then I either add, as you suggested, sodium hydroxide, or these are 20% by weight, or 20% by weight hydrochloric acid. Let's do the hydrochloric acid here. Let's go like 2 drops. Give her a swirl. There's your red. Oh, look at that. It was like a whole rainbow there, like a whole swirl of rainbow. I didn't add enough acid. I got to keep that in mind next round. Here we go. Welcome there, Comedy. Hey, by the way, if you guys want to check it out, I've got some T-shirts you can buy to support the channel. I know nobody wants a T-shirt with my name on it, so gosh, that was gorgeous, really pretty. So I made some like designs that I thought people might like. This one was my favorite. So many experiments, so little time. If that's something you think you might like on a T-shirt, you might want to go to my my merchandise page. You can see that on right here on my YouTube page. Here's another one that I like. I might come out with some more ideas. This is sort of my tagline I've had for a long time. I've never had a failed experiment, only new observations. So there's a couple things you might want to check out on my merchandise page. You can find the link right there on my main channel. All right, enough of that business. Thank you there, Comedy. Yeah, be sure to, drop me a line. Here's a couple drops of hydrochloric acid. Let's go like 4. That's a great way to support the channel and, get a little merchandise at the same time. So we added the hydrochloric acid. I appreciate that, Comedy. Can I do a complexation titration with EDTA? Simon, what a great idea. Unfortunately, I don't have Ariachrome black tea here in my basement. I guess you can probably guess why that's so. But I may be able to get that and set it up in the lab sometime. That's a great idea. Do I have an acid that's less dense than the liquid in the beaker? I think the diffusion would look cool. All right, Allie, here we go. We're going to set up a different experiment for Allie. Just give me a second over here. It's going to take a little bit just for me to get this going. Here we go. We'll do the regular old experiment here. It's going to just take just a bit for me to get set up. We'll switch over to this experiment that does some interesting things that Ollie suggested. Just trying to get everything to look right here in a moment. Turn this around. Turn this off. Let's add some distilled water. In it goes. All right. Get the tornado going, baby. Let's get the tornado going. I just want to get this focused on the flask just a little bit better. Just a bit. Pull this up. That looks nice. Okay. Now let's add the universal indicator, also known as a rainbow indicator. Let's see what happens here. I'm going to pull it up. And you'll notice as I pull it up, it's green in color. See that? Nice green in color. We're going to go ahead and add it to our spinning vortex. And we do that, you can see it turns yellow. And that tells us that the water is slightly acidic. Those that watch this channel long enough, they know that that slightly acidic nature of any water that's exposed to the atmosphere, as long as nothing's dissolved, like purified water, that's from dissolved carbon dioxide from the air. So that's where that comes from. All right, we're getting our lights nice and ready here. So you can see how this experiment gets set up. All right, baby, here we go. Let's show you what's going on here. Let's add a couple drops of hydrochloric acid. Here we go. And that's going to shift us to the red color, of course. And now we're going to add the sodium hydroxide. Maybe get the rainbow here. I'm hoping we get a flash of the rainbow. Come on, baby. Nope, a little bit. The base is a little too concentrated. Try adding a few more drops of acid here. See if I can get another shot. A little bit more. All right, I'm going to do 2 drops of the base. See if this works. 1, 2. See if we get the rainbow action going on. Come on now. No, that's going straight. That's going straight pH 10 from pH 3. So I'm going to have to try just 1 drop. Come on now. Yeah, I'm a scientist user. Hello there, Rini. Maybe in the reverse direction, that looked like it may have gone a little bit. Rainbow action. Here we go. Let's add a couple drops. 1. Let's just give it 1. See what happens. Not enough. Let's give it another. Boom. One more. Keep going. We're going to get there. Bala, we got a chemist that enters the chat. Welcome aboard, Bala. Thank you there, Ashley. Come on, man. Come on, give me the rainbow. No, we got to keep going here. I'm adding base to neutralize the acid. Hello there, Momon. I think this is going to be the winner. Come on, we got a little flash. Get in there. There it is, folks. This is going to be it. This is going to be it. There's your rainbow, baby. Little flash of rainbow for you. Good evening, Rini. We got someone from London has entered the chat. Hello there, you Elvis. Maybe it needs some buffer. You're right, Lord. I know you're right. So in the next flask, we're going to set up my tap water, all right? So let's back this up so we can see two flasks going on at once. This one over here on the left, we're going to acidify. So here we go. We're going to acidify it. Okay, then turn this off. We'll let that set for just a bit. On this side, I'm going to add some tap water. Here we go. Hey, someone here from France. I love it. Welcome aboard. Welcome aboard. All right. The rest, we're going to go distilled water. Okay, now the flask on the left. Hello, administrator. What's going on? We got someone from the Netherlands here. I'd love one, Sean. I'm going to add a few drops of sodium hydroxide over here on the left. Notice when I add it, you can see that the sodium hydroxide solution is more dense than the surrounding fluid, and that's why it sinks. Now, on the way down, it's going to react with the acid, and it's going to neutralize it. And if this works right, we may get a pH gradient here. If you want to see more about that, I did a YouTube short on that. Sam from Somaliland. I apologize if I'm not saying that correctly. The reason for the colors is that I've added universal indicator to each flask. Universal indicator is also known as rainbow indicator, and that's just something that changes color depending upon pH. Got someone from Bulgaria here. Wonderful. Welcome from everybody all around the world. Glad we're all hanging out together. A buffer, Ashley, is something that resists changes in pH. And by resisting the changes in pH, we won't see that drastic change like we're seeing here from, pH 10 to pH red. We want to get some of the, the middle colors involved. Administrator from Hungary. Looks like a tornado. It does look a bit like a tornado from the bottom up. Here we go. Let's go ahead and acidify this. All right. A little bit more. And now let's give a drop of base and see what happens. Thanks for all the likes, everybody. I appreciate that. Someone from Portugal. Thank you, Richard. Welcome aboard. I've been doing okay, administrator. Hope you've been doing okay, too. Look at that over on the right, baby. Come on now. We got a little flash of rainbow going on. Yeah, we can increase the speed of the tornado. Here we go. I'm gonna bump it up over here on this side. Look at that. Look at that gorgeousness. Come on, man. We got the rainbow going on. Over here, it looks like we just got, basically pH 3 at the top and pH 10 down at the bottom. That's cool to hear, administrator. Let's go ahead and turn this one on over here on the right. Mix it all up. See if we have more acid or base. We definitely have more acid present. Let's add a few more drops of base here. See if we can't get a pH gradient going over here on the left. I'm going to go ahead and add some acid here on the right. Here we go. I see someone commenting to drop a super chat. Don't worry about that. If you wanna support the channel, I tell you what you can do. You can certainly go to my merchandise page and you can get some stuff there. I try not to put stuff with like Tommy Technetium on it. Nobody wants that. But I try to do stuff that's kind of science focused. So, you know, if you think a t-shirt or a sticker or something like that with something on it that might look like this, so many experiments, so little time. If you like that design on a t-shirt, you might want to pick up one of those on my merchandise page. Here's another one that I got there. There's other designs as well. I've never had a failed experiment, only new observations. Really plain. That one's a plain experiment. Thank you there, Comedy. Yep. So yeah, you can get, like, you know, if you don't want to spend a whole lot, you spend like $3 and get a sticker and support the channel. That is that's the, what is it? The URL. You can find that on my, you know, YouTube page as well. Let's get back to the science though. Enough of that crap. Here we go. Let's go ahead and add a bunch of acid over here on the left. Hello there, Noel. Yep, Comedy, I'll do that at the end of the live stream. If folks are ready for that, I'm happy to turn it around when I can just talk to you. But that's what I do at the end of the live stream. If you want to see what it'll look like, I turn it around. There's nothing to write home about. I'm a 57-year-old man doing experiments in my basement. So, you know, if that's something you want to see, you can hang out. If not, what's my acid of choice? Bevan, the acid I'm using is hydrochloric acid. Look at that gorgeousness. That was really cool there for a bit. Whoa, that was cool. Look at that. Come on, man. That's just awesome. Hey, administrator, I had a question. They said, hey, what causes an element to be radioactive? So what causes an element to be radioactive is its nucleus is unstable. So you might remember that in the nucleus of an atom, there are protons and neutrons. There are some combinations of protons and neutrons that will survive, so to speak, for a little while, but ultimately they fall apart into other stuff. Gosh, we are getting some interesting results over here. We have got to focus in on that. And so that's what causes an element to be radioactive, is if its nucleus has unstable numbers of protons and electrons. Excuse me, protons and neutrons. The molarity of hydrochloric acid and sodium hydroxide, I'm using Bevan. In this experiment, I use 3 molar sometimes. I think today I'm using 6 molar, thus the gloves. Yeah, it does, Artie. It looks a little bit like a galaxy for sure. It is a little mesmerizing. It's like the Northern Lights, man. I heard we may have been able to see the Northern Lights last night. I didn't get out to see. Look at that. I didn't get out to see them. What happens when I run out of acid or base drops? I get some more. I know how to get it. Why did the camera switch? I just sometimes want to focus on different aspects of the experiment. And this one, I'm really kind of mesmerized by the colors here, which is why I'm kind of focusing over here on the experiment on the right. This one, I just really have the colors working well, and I don't always have this interesting look of a color, which is why I'm just fascinated with it, and that's why I'm fiddling around with it. Bevan, I understand that. 0.1 molar, that's not going to do much damage if it gets on you. No, Samatar, this would not explode. This is not strong enough stuff to explode. It's just gorgeous, though. My goodness gracious. I am finding this really fascinating. The colors are just popping today. Will it blend? I guess in a sense we are blending it, huh? Yeah. Iani, it will continue to change color as long as I continue to add either acid or base. Right now I'm adding base. When I add base, it's going to shift the pH to a higher pH, and so it's going to look more violet. Now I'm adding acid, which should lower the pH, and that'll shift it to the red end of the color spectrum. Maybe, Lord, I don't know. Maybe it's the buffer effect that's doing it. I really honestly don't know. I agree, Jim. I definitely agree. And we got a little bit of a pH gradient going on over here. Just a bit, you can see. You can also see, look, there's a little bit of acid that's sinking down into the surrounding base, which is kind of cool. That's some high entropy. Come on, Canopy. Canopy's winning the comments right now. Well done. So what's in the glass? Focus, focus. What is in the glass is some water and some pH indicator that displays various colors from pH 3 to 10. It displays the colors of the rainbow. Red at the acidic end, which is where we are now. And as I add base, it will start to shift to the blue end of the color spectrum. And every once in a while, we get like a rainbow. We get the pop of a rainbow. I don't know, Lord. It's something in my tap water. How you doing there, fruit? Fish of the United States of America? Zamseer or Zamkire. We're almost there. So neutral is green. I'm going to try to add just a bit of base to get us there. Here we go. I'm going to add just a smidgen of base. And we'll see if this gets to green. If it's green, I've neutralized everything. I think I went too far. Can I repeat the pattern? Probably not the pattern. That's pretty close. This is kind of like pH 8. It's kind of like an aqua green. I'm going to try to get this to... I had to just... There we go. Oh, it was neutral for a second. Administrator, something can be pH 15. It's just that, you know... yeah, something can be pH 15. That's exactly right, Zam. Yeah, we had it for a second, Artie. Wow, that's really cool, Bevan. You've worked on CRISPR. Come on, man. That is just cool. What is the maximum pH? Man, I think there's like... They're up there, man. I think there's stuff that's got like pHs of 30 or 40. But if there's some chemists in the chat that know better, you're organic chemists, you make sure you correct me on that. It was there again, Yanni. That's correct, Lord. Negative pH can be a thing. And in fact, the stuff that I'm adding does have negative pH. This has negative pH. And this would probably have a pH of like, oh my goodness. This could have a pH of like 15 or 16, this stuff here. You got it, Bevan. Bevan the chemist has entered the chat, helping me out. Come on, man. Bala, it'll stabilize when I quit adding either acid or base. I'm continuing. If you look up here at the top, you can see that I'm continually adding either acid or base, and that's going to change the color. And when I stop doing it, it'll stabilize. Yeah, after a while, Lord. It wouldn't hurt right away, but I'd notice it if I left it on there. Yep. Hey, Alicia, welcome aboard. We got a member aboard. I appreciate that. Sounds like my wife is home from work, and that means pretty soon I'm going to stop the live, okay? And that means I'm going to be flipping the camera around. Right now it's basic, Bala. So I'm going to be flipping the camera around. If you don't want to see a 57-year-old man in their basement, now's a good time to get out of the chat, okay? I hope that works, Amsire. We'll talk to you just for a little bit. All right, let me turn the light on. Momon, I just save it. What if you make it violet, then try to... Okay, let's do that. We're going to make it go violet and go backwards. Hey, thanks, Sir Bevan. I appreciate that. Hope to see you around. Okay, so now it's at violet, and we're going to send it in the opposite direction. So let's send, like, I don't know, 5 drops in here. 1, 2, 3, 4, 5. Let's see what happens. It's like the day breaking through the night. Fighting. Looks like we ended up with like a pH, I'm going to say like 6. Let's try that again. We'll get it back to violet. Well, welcome back, Artie. And instead of adding 6 drops this time, I'm going to add 3. We're going to see what happens. There we go. 3 drops of acid. Let's see what happens. Usually EMH, not always. I mean, there's ways to get around it. You can also buy some stuff online. All right, man. Let's flip this thing around. Say hello to everybody. Turn this light on. Oh. Thanks, Air Threads. I bought this shirt for y'all. I hope you like it. Yeah, hey, let me just show you this one more time. If you'd like to support the channel and get something for supporting me, you can maybe consider to go to my main page and check out this link that you'll find on my YouTube channel, Tommy Technetium, Tommy-Technetium.dashery.com. And you might be able to pick up some t-shirts or stickers or all sorts of stuff with designs on it like this. So many experiments, so little time. I know this looks goofy because the camera's flipped. This one is much simpler. I've never had a failed experiment, only new observations. That's what I love about science, you know. You can't fail in science. You know, all you're doing is you're setting up experiments and you're seeing what the universe has to tell you. Thanks, Aldo. Thanks, Air Canopy. Appreciate that. Thanks, Moman. I appreciate that. Appreciate that. Yeah, there's another one on there that says, I usually stop these videos with this particular phrase. I say, hey, you know, the universe is always having a party, but science gets you on the guest list. And what I mean by that is there's beauty happening all around you all the time. Like scientific phenomena are so beautiful. I mean, just like check out the clouds, you know, or look at the grass, watch bugs crawling on the ground, watch the colors change in the flash that I'm using here. It's just, there's so much beauty that's there. And science helps you appreciate that beauty in a deeper way. And so that's why I say that. The universe is always having a party. Science gets you on the guest list. Thanks, Administrator. Me too, Artie. Me too. It is a wonderful thing to explore because, you know, it's just our universe. It's just our stuff, and it's just a joy. All right, folks. Well, thanks for hanging out with me today. Next weekend, I'm not going to be holding my normal live. I'm going to be on vacation, and so I'm going to take next week off. I might throw one in during the week to make up for that. We'll see. But you know, don't be expecting to see me next weekend. I'm actually going to a family member's function, so I'm looking forward to that. And you know, in 2 weeks we'll see you again. So hey, remember, the universe is having a party, and science gets you on the guest list. So long, folks.